Okay, so I'm going to do this problem here. So people enter a line for an escalator at a rate modeled by this function r, okay, given right here. So it's a piecewise function. So it's the top rate for time between 0 and 300, and then it's 0 for greater than 300. So where r of t is measured in people per second and t is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second. There are 20 people in the line at time t equals 0. Okay, so guys, the first thing that you've got to recognize is that this is a rate in, rate out problem. Okay, this right here, oh, and let me actually show this to you. All right, so here's some things that I wrote down. So A of t is the total amount at time t. A of 0, initial amount. AI, the amount that has gone in. AO, the amount that has gone out. RI, rate in. RO, rate out. Now, some relationships between those things. The amount that has gone in over a certain time interval is equal to the integral of the rate. Amount out, same thing. Then if you want the rate of change of the total amount, of whatever is changing, if you want the rate of change, you do the rate in minus the rate out. And then here's the antiderivative with the integral formula. So the total amount at any time t is this. Okay, so things to know. If you know these things and you're able to piece them together, then you can do this problem. Okay, so let's say, all right, so this is the rate in. They exit the line at a constant rate of this. That's the rate out. There are 20 people in line at time t equals 0. So the amount at time 0 is 20. So how many people enter the line for the escalator during the time interval 0 to 300 seconds? Guys, so I want the total amount that went in. So I do the integral of the rate. And you could just say r of t. All right. Then you go to your calculator. I already did it. You do math 9, and then you plug this in, and then you're going to get 270 people. Okay, now part B. During the time interval 0 to 300, sorry, this is not focusing well. There are always people in line for the escalator. How many people are in line at time t equals 300? So I'm going to let A of t be the amount of people in line at time t. All right. Then I know this, guys. I know that A of t is going to be A of 0 plus the integral from 0 to t A prime of w dw. That's the antiderivative with an integral formula. Okay, but guys, what is A prime? A prime is the rate in minus the rate out. So A of t is equal to, this is 20, plus the integral from 0 to t. The rate in is r minus the rate out is constant. It's 0.7. Okay. And I want A of 300. 20 plus the integral from 0 to 300, r of w minus 0.7, dw. Okay, you plug this whole thing into your calculator. Oh, and by the way, guys, I just want to show you something that would make life simpler. Okay, so let's say, shoot, never mind. I was just going to show you, like, instead of plugging this in from the beginning, I just accidentally cleared my calculator. But since I already typed in this integral for part A, I can go back to it. I can highlight it in my calculator, like this integral, and hit enter, and that'll bring it down again. And then I could just go inside here and put minus 0.7. So instead of typing the whole thing over again. And then what we end up with here, I believe is 80. Yes, 80. 80 people. Okay. C, for t is greater than 300, what is the first time there are no people in line for the escalator? So guys, for this one, we could use an integral, but let's just think of it this way. At t equals 380 people in line, okay? No more going in. 80 people in line, and rate out is 0.7 person per second. All right, so if there's 80 people in line and they're leaving at a rate of 0.7 person per second, then how long would it take for all 80 of them to be gone? You just divide. So it'd be 80, and if this isn't clear, please let me know. 80 divided by 0.7. 80 divided by 0.7 is 114.2857143. So it's 300 seconds plus 114.286 for 14.286 seconds. Okay, that's how long it takes for there to be nobody left in line. Okay, now the very last one. This is going to involve the candidates test. So for this time interval, 0 to 300 seconds, at what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time, justify your answer. Guys, we're going to need the candidates test. Okay, so candidates. This is part D. Candidates test. All right. So T, A of T. All right. You don't have to set it up exactly the way I do, but we've got 0 and 300. Those are the endpoints. And here we need the critical numbers. So A prime of t equals 0. That's what we want. So what is A prime? A prime is the rate in minus the rate out. So that's going to be R of t minus, no. R of t minus 0.7 equals 0. That's what I want to find. So I go to my calculator. I go to y equals. I already plugged it in. So I've got R of t there minus 0.7. I go to my window. I only want to see, I want my leftmost x to be 0, my rightmost x to be 300. And there's the graph. Okay, so we've got these 2 points where the derivative is 0. Okay, so I'm going to find them. So we're only going to have two critical numbers between here. Yeah. All right, so let me find this first one. Second calc, 0. Okay, left bound, right bound, yes. Okay, so 33, so I'll put right here, 33.013298. I will store that as B, guys, because I'm already using capital A. So now I go back to the original, or back to the home screen. I hit X. I'm going to store that as B. All right, now back to the graph. Oh no, 0. To find that next 0. Okay. 166.57472. I'll store that as C. I'll store that as C. Store C. Okay. Now I've got to find these outputs here. So A of 0, we already know that's 20. And we actually already know A of 300 also. We found that. A of 300 was 80. I found that earlier. Now I just got to find these ones. So A of B is going to be 20 plus the integral from 0 to B, R of W minus 0.7 dW. Okay. Now earlier, all right, I'm just hitting second enter till what I want comes back up. Okay, so here's this integral. I already had, it's kind of hard to see, sorry guys. I already had that integral typed in, so I just kept hitting second enter till it came up again. So I plugged in 20, and then from 0, and then up here, I just want to change that C to a B. And then I've got everything else in there as I want it. Okay, 3.803. 3.803. Now I've got to do the same thing. So I'll go up, I'll highlight this, and I'll hit enter, and it'll bring it down. And the only thing I want to change about this now is this upper limit. So I changed that to C. 158.070. Oh, so this is A of C is 20 plus the integral from 0 to C, or 158.070. All right, so they want to know at what time does the absolute min occur. It's occurring at this. All right, so the answer is 33.013 seconds. So min occurs at t equals that. And min equals, they want us to round up, so 4 people. Okay, it occurs here, and this is what it is. Okay, I hope that was clear.